Good morning, dear students. How do you do? Hope you are all fine and safe. After Dasara holidays, we are meeting again in our online classes. Before holidays, we were discussing about the lesson metals and non-metals. In that, some of the topics we covered already. Through some activities we studied the reactions of metals with a number of reagents like acids, water, oxygen, etc. Why do metals react like this? And in our 9th standard also you studied about noble gases, which are zero group elements or their valency is zero. That you studied about them, which have a completely filled valence shells. You studied in your lower classes, 9th standard, isn't it? Today we are going to study how do metals react with non-metals. How do metals react with non-metals? And why do they must react? That all we are going to take up in this today's concept, that is metals and non-metals react. Here you can observe, children, sodium, and here chlorine. Sodium is a metal, chlorine is a non-metal, and you can observe here Bohr's model. It shows the arrangement of electrons in both sodium and chlorine. By using this, we can study about how do metals and non-metals react with each other. Completely filled shells or octet structure must be there in their outermost shell. Neon, 10 atomic number, is having 8 electrons in its L shell. Argon, 8 electron in its M shell, like that. Now let us come to metals. Metals like sodium having 1 electron in its outermost shell. These are valence electrons, children. Remember, these are our valence electrons because they are taking part in the reaction. Magnesium having 2 electrons, aluminium 3 electrons in its outermost shell, potassium 1 electron, calcium, like that, 2 electrons. When we come to non-metals, nitrogen 5 electrons, oxygen 6 electrons, like this. When we come to chlorine, chlorine is having 7 electrons in its outermost shell, isn't it? Now how do they react? Metals and non-metals, how do they react? The nucleus of the atom and the surrounded electrons are there, no? What happens when the metals react with the non-metals? Let us take up the example of sodium and chlorine itself, children. Let us take the example of sodium. Sodium is a metal. As you know, sodium is a metal. It is reacting with, let us consider chlorine. Okay, sodium is a metal and chlorine is a non-metal. How do they react? First of all, what is the atomic number of sodium? Sodium atomic number is 11. Let us write the electronic configuration. Last year you studied about that. 1s2, 2s2, 2p6, 2s1. Sorry, 3s1, correct? 4, 10, 11. This is K shell, L shell, and this is M shell. Now, it wants to react, means that in the valence orbit, that is in the outermost shell, this is the outermost shell, now M shell, in that the electrons are taking part in the reaction. What happens if it loses 1 electron, children? Think here now. If sodium loses 1 electron, it becomes octet here. 2 plus 6, 8. Outermost shell becomes L shell now. And it gets 8 electrons. So what happens? This will be the outermost shell. So it becomes, it is getting octet. So what happens? Sodium becomes the donor of electrons. It gives up electrons. So that it can become octet. So when it loses 1 electron, it becomes octet structured. Understood, no? So what happens? sodium as an atom. It is in the atomic state, that is atom. Sodium, its configuration 281, K shell 2, L shell 8, M shell 1. It loses one electron. When it loses one electron, always remember children, it becomes a sodium cation. Cation means whenever any atom loses electron, it is known as cation. It becomes cation, and here what happens? The electrons, actually there will be 11 electrons and 11 protons. But what happened here? The protons will be 11 itself, but electron one lost, no? So it is a 10 electron. So net nuclear charge will be positive 1. 1 electron so is lost, so it is getting positively charged and it loses 1 electron. Correct? So what happens? It is in the atomic state and it has converted into sodium ion, that is that ion, positive ion, because it has lost 1 electron. Whenever any atom lost electron, it is a cation. And now let us take up chlorine. What is the, let us write now chlorine. What is the atomic number of chlorine? 17. Let us write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p5, K, L, and this is M shell. Now here what happens, children? Chlorine. Chlorine, here in the outermost shell, now these are the this is the outermost shell, M shell is the outermost shell. Here how many electrons are there? Totally 7 electrons. So these 7 electrons need 1 electron to become octet, right? They need 1 electron to become octet. So chlorine will receive 1 electron. Chlorine will receive 1 electron. Here it is plus. Chlorine will receive 1 electron. And here it is in the chlorine atomic state. It is atomic structure. Chlorine 2, 8, 7 it was there. Whenever it receives 1 electron, it becomes negatively charged ion. Net negative charge will be there because in its nucleus there will be whatever protons are there, that is less than that of the electrons. So 1 electron more will be added to the structure, so it gets negatively charged. So it becomes 2, 8, 8. See here it has got octet structure, and now it is a chloride anion. This is anion. This anion is known as chloride ion. Anion means negatively charged ions are known as anions. So what happened? Here chlorine, the ion is got. Now how do they react? Here in this structure it is there. Whatever here in the sodium has lost 1 electron, and that electron is received by chlorine and it becomes again chloride ion. As sodium ion and chloride ions are oppositely charged ions, there will be present electrostatic force of attraction between positively and negatively charged ion, and it forms a crystal of them. Attraction between them exists and they form sodium chloride. They form sodium chloride. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. So what happened now in the end? Sodium, as it is positively charged ion, it has 1 electron in its outermost shell. This is a method of showing dot structure. Lewis dot structure we are used to say. Dot structure, the electrons in the outermost shell, in the valence shell, are denoted by a dot, sodium. And here we get chlorine, isn't it? Chlorine in its outermost shell, how many electrons are there, children? 7 electrons. You have to show it by a cross mark or into mark. 1, 2, 3, 4, 5, 6. Here 1, 7 was there, and it receives 1 electron from sodium. Correct? It receives 1 electron from sodium and it becomes a sodium plus, children, it is. And here chlorine will be 8 and it receives 1 electron. Whenever it receives 1 electron, it is negatively charged. So remember this, it is a negatively charged. Positive and negative, there will be electrostatic force of attraction between these two, and this gives rise to Na plus Cl minus gives NaCl. This is the principle behind the, here you can observe, children, Na plus and Cl minus between them, and force of attraction, they will remain as sodium chloride. It is a crystal. Here which bond is there, we say? We used to say ionic bond, because there is the force of attraction between two ions, two types of ions, oppositely charged ions. So it is a ionic bond present between them and it forms a crystal of sodium chloride. This is very important, children, from the exam point of view. Now let us consider another one. Let us try to find out the formation of a magnesium chloride. How it forms magnesium chloride. Let us take up magnesium. Its atomic number is 12. Let us try to write the electronic configuration of magnesium. 1s2, 2s2, 2p6, 3s2. Correct? K, L shell, and this is M shell. Now, let us take up magnesium. Okay? Now, let us take up magnesium. 282. Correct? It is 282. Electrons are written here in each shell, 282, and whenever it wants to react with the chlorine, let us see, magnesium chloride, we are finding out the formation of magnesium chloride. So, it becomes magnesium and it will lose 2 electrons. Clearly you can see, observe, children, if it loses 2 electrons, it gets octet structure, correct? 6 plus 2, 8. So, it gets octet structure, children. So, magnesium loses 2 electrons and it becomes magnesium cation. It becomes magnesium cation and 2 electrons are released there, isn't it? Given up. 2 electrons are lost. And now what happens? Again, chlorine we have to consider, isn't it? Chlorine we studied already, 17, 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p5. Here you can observe, children, K, L and M shell. So here chlorine is in the form of 2, 8, 7. Correct, no? Here what happens? It will receive these electrons. So what happens here? It will receive 1 electron and it becomes chloride ion. This is an ion of chlorine. That is chloride ion. So here, but observe, children, here 2 electrons are there actually. Here 1 chlorine atom needs 1 electron. So we need 2 chlorine atoms so that it can react with the 2 chlorine atoms to react with the 2 electrons given by magnesium. So here 2 chlorine, here 2 chlorine needed there, and so we are getting 2 chloride ions here. Correct, no? So we are getting like this. Now, how do these two react, form the bond? Which bond? Ionic bond. How they form the bond, let us see. Now, magnesium is having how many? 2 electrons in its outermost shell. Correct, children? Yes. They are having 2 electrons. And what I told you, this magnesium has having 2 electrons, but each chlorine atom needs only 1 electron to get octet structure. So, it combines, chlorine combines with the 2 chlorine atoms. 2 chlorine atoms, here you can observe 2 electrons, 2 electrons, 2 electrons, here 1 here received by this. 1, 2, 3, 4, 5, 6, 7, here 1 more 8, see. And another chlorine same way, here 2 and 1 electron received by this chlorine atom. In this way, magnesium gets combined with 2 chlorine atoms to form the bond and to react with each other. And so what happened here now? Magnesium reacting with this gives what? Here you can write magnesium 2 plus, you must write, children. And here chlorine 2 like this, and here 1 more 2 minus you must write here, because it is reacting, sorry, here minus you have to write. Here you have to write minus, here 2 plus. Magnesium has lost 2 electrons. So here you can observe. And how we are writing now? Chlorine react with this and it gives MgCl2. Last year we studied how to write the molecular formula. Here their valencies are exchanged, children. As we studied magnesium valency 2 in the last year's class 2, 1. So it is MgCl2 we used to write, correct? So we used to write like this. So this is the molecular formula of magnesium chloride. In this way we have to understand. Understood now? This type of bond is known as ionic bond. Now let us take up one more. Formation of sodium oxide. How it is formed? Formation of sodium oxide, let us see. Sodium, as you know, it is having 281. We studied already. So I am not writing in a full form manner. 281. So what happened here? Here it becomes Na plus and 1 electron is released per each atom of a sodium atom. And now let us consider here oxygen, children. Let us consider now oxygen. Here oxygen atomic number 8. 1s2, 2s2, 2p4, 224. Correct, no? 8. This is a K and L shell. So, what happened now? Oxygen atom, it was having 2 and 6 structure, electronic configuration. When it receives 1 electron, but observe, children, here in the outermost shell, how many electrons are there? 6 electrons are there. Then what is its valency? Its valency is 2, because how much it is needed to become octet? It needs 2 electrons to become octet. So its valency is 2. But from sodium we are getting only, from one sodium atom we are getting only 1 electron. So what does it mean? It means that one oxygen atom needs 2 atoms of sodium to form sodium oxide. So let us write first oxygen. It receives 1 electron, correct? It receives this electron from sodium and it becomes what now? It becomes 2 minus, correct? But here you must write here 2 that is here it needs 2 minus, because oxygen has become oxygen 2 minus. Correct, children? Then it can become 28. Understanding now? Now, let us take up how to write the structure now. Here actually what oxygen needs 2 electrons to become octet, children. Understanding now? Here how we are writing 2 minus here? It is getting from 2 sodium atoms. Whenever 2 sodium atoms are there, we are getting 2 electrons, children. 2 sodium atoms means 2 electrons, and here also it is 2 plus it will become, and here again what happens, 2 electrons are taken and here it becomes 2 minus. In this way we can write. And so what happened here now, sodium, it is plus, and here is it enough to write like this? No, we can't write like this. What we have to do now? We have to write sodium. 2 sodium atoms are necessary here to write the structure. Here oxygen is there, children. Oxygen, how much it is? 1, 2, 3, 4. What was in the end? There were 6 electrons in the outermost shell. Write that first. 1, 2, 3, 4, 5, 6. Only 6 were there. And what happened now? 1 electron from sodium. This is the dot structure of sodium. And this 1 electron is added to oxygen. Here also, what happened? It is added to this one. So, 2 electrons are received by oxygen and it gets octet structure, children. So, electrons in the outermost shell becomes 8. Correct? 1, 2, 3, 4, 5, 6, 7, 8 electrons are got. Understanding now, children? Like this. And it gives the structure like this we can write. See, Na plus 1 electron. Here 1, 2, 3, 4, 5, 6, 7, 8. Here it is 2 minus. And here we are writing Na plus again. Here see. Na and 2 minus. So what happened now? The valency of sodium is 1, oxygen's 2, so cross multiply. That is Na2O. It becomes Na2O, children. Its structure, that is molecular formula, becomes a Na2O. That's why it gets like that, because for combination, to form the compounds, oxygen needs 2 sodium atoms to get octet structure. So we are writing sodium 2, Na2O. Understanding now? Yes, very important from the exam point of view. Children, let us know how do metals react with non-metals. In our last year classes, you studied that there are noble gases, metals, non-metals are all there. Noble gases, example helium, neon, argon, you can see here. And their atomic number is given, helium 2, neon 10, argon 18, like that. And on the different shells, you can observe, children, the structure of an atom. Actually what there will be nucleus at the center and the electrons are revolving around the nucleus. At the center there will be protons and neutrons. We know that, isn't it? And electrons are revolving around the nucleus. And these electrons take part in the reaction, isn't it? When they are reacting not only in one circular orbit, in a different circular orbits, the electrons are revolving around the nucleus, and whichever the electrons orbit takes part in the reaction, electrons, those are known as valence electrons. The electrons which are taking part in the reaction are known as valence electrons. Let us look at this. And different shells are there. K shell, L shell, M shell, N shell. In these shells, they are arranged. Electrons are arranged, you know. So here, as you know, noble gases have completely filled shells. Here in their outermost, how do we mean? What do we mean? The completely filled shell, they must have octet structure or completely filled shells in their in their completely filled shells. Children, till now we studied about the metals and their reactions and all. And now, where do we get metals? The Earth's crust is the major source of metals. You can see from the Earth's crust we will extract metals. Seawater also contains some the soluble salts such as sodium chloride, magnesium chloride, etc. Isn't it? The elements or compounds which occur naturally in the Earth's crust is known as minerals. Actually, they are naturally occurring. At some places, minerals contain a very high composition or percentage of a particular metal, and all the metal can be profitably extracted from it. Whichever the mineral from which we can extract the metals profitably, those are known as ores. The metal ores. From which ores are the substances from which we can profitably extract a particular metal. That is known as a ore, and it is containing high percentage of particular metal. Okay. Now, on which basis we are extracting metals, children? Reactivity series we studied in the previous section of this lesson itself. We studied about the reactivity series, isn't it? Having this knowledge, we can understand easily how the metals are extracted from their ores. We can, remember children, we can get metals, we can extract metals from their ores, respective ores. Some metals are found in the Earth's crust in the free state, isn't it? Which one? That is, you can observe here, they are kept in the bottom of the series, reactivity series. You can observe, children, that is the gold. Gold is got in the native state in the Earth's crust. Some are found in the form of their compounds because they are having the feasibility or tendency to react with the moisture or air, etc. or acids. So, they are got in the compound state. The metals at the bottom of the activity series are the least reactive. You can observe, children, in the bottom of on the screen. You can see at the bottom of the reactivity series there are the silver and gold. Gold is at the bottommost part. That is, gold is found in the native state, in the free state, in the nature, in the Earth's crust. For example, gold and silver and platinum also. And somewhat copper, silver, little bit reacting, but gold is purely in the free state. It is in the Earth's crust. Copper and silver are also found in the combined state as their sulfides, oxides. Like that we can get copper and silver. But gold is very much the purely got in the free state, in the nature. The metals at the top of the reactivity series like potassium, sodium, calcium, magnesium, aluminum, you can observe there, children. They are so reactive that they are never found in the nature in free state. The metals in the middle of the activity series like zinc, iron, lead, copper, etc. are moderately reactive. They are not too much reactive and they are poor reactives, like that. They are in the middle of that. So, they are moderately reactive and they are found in the Earth's crust mainly as oxides, sulfides or carbonates. For example, zinc sulfide, like that. They are occurring as oxides, sulfides, sometimes carbonates, like that. Many of the metals are in the oxide form. This is because oxygen is a very reactive element and a very abundantly available on the earth. Oxygen, as you know, is in abundant quantity in nature. So, the metals are mostly reacting with oxygen to get oxides. Thus, on the basis of reactivity, we can group the metals into the following 3 categories, children, which are all metals of low reactivity, metals of medium reactivity, metals of high reactivity. You can observe, children, here on the topmost, whichever they are metals of the high reactivity, which are in the middle of the series, they are metals of medium reactivity, and which are at the bottom of the reactivity series, they are metals of low reactivity. In that type, there are 3 categories on the basis of which we can categorize the metals. And whichever on the topmost of the series, they are extracted using the process electrolysis. You can see there. And whatever in the middle of the series, the metals are in the middle of the series, they are extracted by the reduction using carbon. And anyway, gold and silver, they are found in native state. So no need of extracting them. They are in the native state in the earth's crust. Understood, no? Yes. Children, as we studied in the previous video, the formation of the combination of metals and non-metals, the compounds formed in this manner by the transfer of electrons from a metal to a non-metal are known as ionic compounds. Here the bonds are formed by the transfer of electrons, children. You can observe by the dot or arrow mark, the cross mark or into mark, we observed that, isn't it? The complete transfer of electrons from metal to non-metal, or like that, vice versa. This is known as a ionic bond. The compounds formed in that manner are known as ionic compounds. We can give the examples as we studied, that is sodium chloride, magnesium chloride. Those are all the ionic compounds, children. Here you can give more examples: sodium chloride, lithium chloride, calcium oxide, magnesium chloride. These are all the examples of ionic compounds. See, ionic compounds, when we take, for example, sodium chloride is an ionic compound. You can observe, children, taking salt solution. This experiment you can also do, I think, at home. Taking salt water and 2 electrodes you can make, 2 nails you can take and connect them with a wire, 2 nails with a wire, or graphite rod. In the battery you can get graphite rod and you can connect it to a battery and a bulb. When it is switched on, you can see that the bulb glows. You can observe that bulb glows because we have added salt solution in the beaker. In the beaker, it is a salt solution is taken in the beaker. So we can observe that the current flowing in the circuit and the bulb glows. Why this happens? Because the ionic compound, sodium chloride is an ionic compound. They conduct electricity. By this we can prove that they are conducting electricity. So then what are the properties of ionic compounds? These ionic compounds, let us see. What are the general properties of ionic compounds? If you take physical nature, ionic compounds are solids and are somewhat hard, like sodium chloride, magnesium chloride. They are all hard because of somewhat hard, and they are solids because of the strong force of attraction between the positive and negative ions, cations and anions, as we mentioned in the earlier video. These compounds are generally brittle and break into pieces when pressure is applied. In the same way, like crystals, isn't it? Salt crystals. When we apply pressure, it will be broken. So it is a physical nature is a solid and it is somewhat hard and they are brittle. What about their melting and boiling points? Ionic compounds have high melting and boiling points. They have high melting and boiling points. This is because a considerable amount of energy is required to break the strong interionic attraction, because there will be always a strong force of attraction electrostatic force of attraction will be there between positive and negative ions. Understood, children? There will be strong electrostatic force of attraction will be there between sodium plus and Cl minus. If you take, for example, sodium plus and Cl minus oppositely charged ions, they will have strong electrostatic force of attraction. To break them, it needs much energy. So their melting and boiling points are very high. What about their solubility? In which one they are soluble? Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. See, electrovalent compounds, this is ionic compounds. They are generally soluble in water. Sodium chloride, generally soluble in water, isn't it? And insoluble in solvents. They are not soluble in kerosene, petrol, etc. They are all inorganic solvent, that is organic solvents like kerosene and petrol, they are not soluble. Next, conduction of electricity. As I mentioned earlier, sodium chloride is conducted electricity. The conduction of electricity through a solution involves the movement of charged particles. Why they conduct electricity, children? Because of the formation of ions there. Through a solution involves the movement of charged particles. A solution of an ionic compound in water contain ions which move to the opposite electrodes. For example, Na plus will move towards, it is a cation, it will move towards cathode because negatively charged electrode, negative part of that. And chlorine is there. Chlorine is an anion because it is a negatively charged particle. It will move towards anode, positive terminal of the battery, like that. Because of that, there will be conduction of electricity. Ionic compounds in the solid state do not conduct electricity. Remember, children, always sodium chloride in its solid state will not conduct electricity. In its aqueous form or in the solution form only it will conduct electricity. That you have to remember. Ionic compounds in the solid state do not conduct electricity. Why they are not conducting? Because movement of ions in the solid is not possible due to their rigid structure. In solids, as you know, they are having rigid structure. Because of that, it cannot conduct electricity. But ionic compounds conduct electricity in their molten state or aqueous state because the ions are free to move about in the solution. This is possible in the molten state because electrostatic force of attraction between the oppositely charged ions are overcome due to heat. Because of heat, they are free to move. Thus, the ions move freely and conduct electricity. These are the properties of ionic compounds.